Okay, so where do aerosols come from? Now, as I mentioned earlier, some aerosols come from human activity. When I spray some stuff out of an aerosol can, I've actually just put a bunch of aerosols in the atmosphere. Aerosols aren't necessarily a bad thing. So I didn't just pollute the atmosphere there. I didn't cause any big environmental catastrophe by doing that. But that is a source of aerosols. Well, there's some other sources as well. Other sources of aerosols include things such as land. So land is covered with lots of dust, and wind kicks that dust up. That adds aerosols into the atmosphere. Our oceans, whenever a wave splashes, inside that wave, there's lots and lots of little salt molecules that end up getting released. That's sea spray. Volcanic eruptions, when a volcano erupts, embedded in that volcanic ash is tons and tons and tons of little aerosol particles. Human sources include things such as factories, cars, power plants. If we start a wildfire, that wildfire can be a source of aerosols because of the smoke. And these are just a few examples. And also, wildfires can also happen naturally. They're not all human caused. So they can also, that can also be a natural source of aerosols. But these are just a few examples of where aerosols come from and what they are. Deforestation is another example. When you chop down trees, that kicks up a lot of dust. That can also create a large amount of aerosol pollution. Here is an example of a source of aerosols. In late 2003, that was actually my first year of college, there was, at the time, the largest fire in California history that formed near San Diego. That fire kicked up a lot of smoke. Embedded in that smoke are trillions and trillions and trillions of aerosol particles. Well, during that time, the winds were blowing offshore, meaning that the winds were blowing in this direction. They were blowing away from the land. And so all of those aerosol particles were blowing offshore as well. The biggest fire that occurred during this time was called the Cedar Fire near San Diego. And this is an image of some of that smoke coming over from the Cedar Fire. And you can just tell, I mean, it changes daylight. It changes how it looks during the daytime. I don't know if any of you lived in San Jose in the summer of 2020. That was the same year that we had the COVID pandemic and everything. There was actually a couple of days in the Greater Bay Area where the smoke was so thick, it looked like it was pitch dark at noon. I like to call it apocalypse sky. And it was really fascinating. That wasn't the Cedar Fire. That was a different fire that occurred in 2020 that caused that. But that's an example of an aerosol-rich atmosphere. Here's another image of the Cedar Fire. You can actually see the flames themselves here. And this was taken from Interstate 15. People were heading towards Temecula from Escondido. And as they were actually passing over into the hills that go towards Temecula, lots of flames were kicking up and a lot of cars had to turn around and get the hell out of there. But all that smoke is made up of trillions and trillions and trillions of aerosols. Here's another image. This is actually from China. So in the northern part of China, there's a desert called the Gobi Desert. And the Gobi Desert is this large desert, and one picked up a bunch of this sand and a bunch of this dust from the ground, and all of that dust was then making its way eastward out towards the Koreas, out towards Japan, and eventually towards North America. Meanwhile, in southern China, Vietnam, Laos, Cambodia, Myanmar, there was a lot of biomass burning that was also occurring. Every year, trees are chopped down and burned, and a lot of that biomass burning results in a lot of smoke and a lot of aerosols being kicked up as well. Notice this date. This was April 7th, 2001, right before I turned 16. And here was 6 days later. All of those aerosols had made their way over to the eastern part of the Pacific Ocean and over towards North America. The same thing actually happens with the Sahara dust down here. It actually makes its way sometimes up into the Gulf Coast of the United States. So this actually happens on both sides of the United States. So the last thing I'm going to talk about before we go on to talking about the force are these things called sulfate aerosols, as well as other types of aerosols. So some of the major players of aerosols. Sulfate aerosols mostly come from volcanoes, though there are some anthropogenic sources, including the burning of coal and other fossil fuels. Most fossil fuels are made primarily of carbon, but there are impurities in there, including sulfur. Well, when you burn that sulfur, it creates this stuff called sulfate, which then gets itself up into the atmosphere. Well, here's the thing about sulfate aerosols. Sulfate aerosols, when they react with water in the atmosphere, they produce this stuff called sulfuric acid. I know that sounds kind of gnarly, and it is, but one interesting thing about sulfuric acid is it is very, 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 very reflective. It is very, very reflective. Sulfate aerosols and the sulfuric acid that they produce is very reflective of sunlight. And therefore, that actually has a cooling effect. That is a cooling effect. Now, here in the United States, most of our sulfate aerosols actually come from the eastern half of the United States, where they rely a lot more on coal burning for power production. On the western half of the United States, we rely a lot more on natural gas, and as well as other renewables, which we'll talk about in a few weeks. So we don't have the same sulfate problem that our friends on the East Coast do. However, overall, the effect of sulfate aerosols is cooling. Black carbon. So if you've ever driven down the interstate and you've seen a big diesel truck next to you, and there's a lot of black stuff shooting out of its tailpipe or out of its chimney, well, a lot of that black stuff that you see is actually black carbon, also referred to as elemental carbon or soot. Its biggest natural source includes biomass burning, so the burning of trees, the burning of grasslands, the burning of any biomass will actually release a lot of black carbon. For human sources, incomplete combustion of coal is actually a big source of this, or incomplete combustion of diesel fuel. A big byproduct of that is some carbon, just plain elemental carbon, ends up getting released into the atmosphere. It doesn't fully combust into carbon dioxide, and so it gets shot up into the atmosphere. And that's why you see coming out of the chimneys of, I always say chimneys, of diesel trucks, you see a lot of that smoke coming out. That's black carbon. It's also referred to as elemental carbon or soot. It is very, very, very fine material. And if you breathe it, it can actually be harmful because it actually irritates your lungs. So you don't want to breathe this stuff. One of the things about black carbon is it's black. And anything that's black has a very, very low albedo, meaning it absorbs a lot of sunlight. As a result, Black carbon actually warms the atmosphere up. It doesn't cool the atmosphere down, it warms the atmosphere up. So I just showed you one aerosol sulfates that cool the atmosphere, and now I just showed you black carbon that warms the atmosphere. Kind of seeing that the total net effect of aerosols is kind of a hodgepodge of warming and cooling effects. Let's look at a few other aerosols really quickly. Sea salt. This is stuff that is released whenever the atmosphere, or whenever a wave crashes onto the beach, or you ever see a big wave that sort of sprays into the ocean, or sorry, that sprays into the atmosphere. Sea salts come from the ocean, and they are highly reflective. They can have albedos as high as 0.97 or 97%. That's more reflective than Venus. So they definitely have a cooling effect because they reflect most of the sunlight that hits them, preventing it from reaching the surface of the earth. Dust. There are all kinds of natural sources: soil, volcanic eruptions, sand, and human sources. If you've ever seen dust in your house, that's a human source. Believe it or not, most of the dust in your house actually comes from your skin. It's dead skin cells. It's dead skin cells. Now, dust, because of its different sources and its different colors, kind of has an uncertain impact on Earth's energy budget. We don't really know if it warms Earth's energy budget or warms Earth or cools Earth. So before we continue on into talking about the force, just a brief review of what we've talked about so far this module. The ozone layer has been damaged by the use of CFCs. That's caused the stratosphere to cool. There have been two main phenomenon due to that: the ozone depletion, which is the overall decline in ozone concentrations, as well as the ozone hole. And then we talked about a lot about these aerosols. And aerosols have two main effects. The direct effect is what the aerosol itself does to our energy budget. And then there's the indirect effect. That's the effect that aerosols have on clouds, which then affect Earth's energy budget. All right, so in our next video, the last video for this module, we're going to tie up all this together and talk about these things called forcings.